Hello everyone. So today we're going to go over section 11.3, connecting graphs and rational equations. So in example 1, we have 16 over x plus 6 on the left hand side of an equation, and on the right hand side we have 4 minus x. And we're going to solve this equation by graphing. Specifically, we're going to graph the left hand side of the equation as one function, and the right hand side as a second function. Okay. So the left-hand side is a rational function with the following asymptotes. We know that y is equal to 0 will be an asymptote because the degree of the numerator is less than that of the denominator. Also, x equals to negative 6 is also an asymptote because from the denominator we know that x cannot be equal to negative 6 and there are no common factors. We'll now go ahead and add in the asymptotes. So next, we will be using a table of values to graph y equals to 16 over x plus 6. We will let x equal to negative 8, negative 4, negative 2, and 2. And the reason why these numbers were chosen is to make it so that the denominator can divide 16 evenly. So for example, negative 8 plus 6 is negative 2. 16 divided by negative 2 gives us negative 8. Likewise, negative 4 plus 6 is 2. 16 divided by 2 is 8. And similarly, we also get negative 2, 4, and 2, 2. So these will be the points on our graph. And we can now connect the points with a smooth curve. Oops, sorry. There we go. Okay. So next, we are going to graph y equals to 4 minus x, which has a y-intercept of 4 and a slope of negative 1. And we can see that there are two intersections, one at negative 4, 8, and the other at 2, 2. So therefore, the solutions to the equation must be x equals to negative 4 and 2. So the main idea for today is to look at how we can solve these equations algebraically. Given an equation like example 2a, 14 over x minus x plus 5 equals 0, the first thing we want to do is to find the non-permissible value, which of course is x cannot be equal to 0. And then afterwards, we're going to multiply each term by x. And as a result, we'll get 14 minus x squared plus 5x equals 0. Then we'll move each term to the right-hand side, which will make factoring easier. And then we can factor this quadratic. And so we get x is equal to 7 and negative 2. Question on the right-hand side is very similar. So first, we find the non-permissible value, which of course is x cannot be negative 2. And now we will multiply each term by x plus 2. Okay, so we'll get x times x plus 2 minus 8 minus 5 times x plus 2, and that will be equal to 0. We can distribute and expand. So we get x squared minus 2x, sorry, x squared plus 2x minus 8 minus 5x minus 10 equal to 0. Here we can combine like terms and get x squared minus 3x minus 18 equal to 0. And then we can factor, as we did in the previous example, x minus 6, x plus 3 are the factors. So the solutions are 6 and negative 3. Now in both examples, we can see that the solutions that we got are not equal to the non-permissible value, so all the solutions can be kept. Okay, so in the next example, part C, we have two different denominators. But the first step, of course, remains the same, and that is we are going to find the non-permissible value. So we have 4x plus 10 cannot be equal to 0. So 4x cannot be equal to negative 10, and x cannot be equal to negative 5 over 2. Notice that the denominator 2 does not contribute a non-permissible value, since there's no variable there. Okay, so next, we are going to multiply each term by the lowest common denominator once we find it. So we can factor out 2 here. We get 2x plus 5. So notice that both the denominators have a 2 in common. And as a result, the lowest common denominator is simply 2 times 2x plus 5. So we multiply each term by just that. So what do we get? We have 2 times 2 times 2x plus 5, first part, minus 3x times 2x plus 5. Notice that the 2's will be eliminated. And that's going to be equal to simply 1 plus 4x minus x squared. So from there we can once again expand. 8x plus 20 minus 6x squared minus 15x equals to the right-hand side, which is just 1 plus 4x minus x squared. Okay, we're going to move everything to the right-hand side to make a quadratic equation. So we have 5x squared plus 11x minus 19, and the left-hand side will be 0. So here we can just use the quadratic formula to find our solutions. And that is to say x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then we can substitute. So we have negative 11 plus or minus 11 squared minus 4 times 5 times negative 19. This is all underneath the square root sign here. And it's all over 2 times 5. And once everything is simplified, we would be left with negative 11 plus or minus the square root of 501 all over 10. Which we can approximate with 1.14 and negative 3.34 using a calculator. And again, neither of those values are equal to negative 5 over 2, so we can keep both of those solutions. Okay. Next example here. So again, we start with factoring. In this case, we'll get x plus 3 over 2 times x minus 3. And that's equal to 2x minus x over negative x minus 3. Which means that the non-permissible value in this case is that x cannot be equal to 3. And now, since we factored all the denominators, we can find the lowest common denominator more easily. We're going to multiply all terms, or each term, by negative 2 x minus 3. So the left-hand side, we are just going to be left with negative x plus 3. The right-hand side, we have 2x times negative 2 x minus 3. And minus x times 2. Once again, we can just expand here. So we have negative x minus 3 equals to negative 4x squared plus 12 x minus 2x. We're going to move everything to the left-hand side and get a quadratic equation out of this. So we have 4x squared minus 11x minus 3, which is equal to 0. And in this case, we can actually factor by grouping. Just going to go ahead and do that. So we have 4x squared minus 12x plus x minus 3 is equal to 0. And we know to separate the middle term as negative 12x plus x, as we are looking for two numbers that have a sum of negative 11 and a product of not negative 3, but negative 12. So negative 3 times 4. So from here, we can group the first two terms together, and the second two terms together as well. factor out the greatest common factor of 4x from the first two terms. And we can also write a greatest common factor of 1 in the second pair of terms. We can now group with 4x plus 1 in the first group, x minus 3 in the second as our two factors, which means x is equal to negative a quarter and 3. And of course, 3 will not be kept as a solution since it is extraneous. Okay. Finally, one more example, just a very simple word problem. So our setup, first step here, is to consider 0.375. We can rewrite this as a fraction 375 over 1,000. Which of course can be reduced to just 3 over 8. So in 21 at-bats, Trent only got one hit. So at the beginning, he had 1 for 21. And then he ends up with a batting average of 375 by getting hits the rest of the way. So every at-bat thereafter is a hit. So let's say Trent has X at-bats remaining, all of which are hits. Then we can have this rational equation. And in this case, we can solve the equation simply by cross multiplying. So we have 8 times 1 plus x is equal to 3 times 21 plus x, which gives us, 8 plus 8x on the left-hand side, 63 plus 3x on the right-hand side. Move the x's to the left-hand side, move the constants to the right-hand side, gives us 5x is equal to 55, which of course means that x is equal to 11. And of course, we can check our non-permissible value. X cannot be equal to negative 21, so we are okay there. So that means that Trent had 11 more at-bats. So that's it. We looked at solving a rational equation by graphing and also algebraically, and that's it for today. So thank you for listening.